looking at our Chapter 4 practice test. This also includes our final exam, so that means that we will be looking at some problems from previous chapters as well. All right, the first one says solve the system by graphing. Now I want to tell you on your test, none of the questions will tell you what method to use. So you may use graphing, substitution, or elimination on any one of them. But remember, sometimes they're set up for one or the other. Just so that we can review graphing, we'll take a look at this first one. The first thing I need to do is get my X and Y axes drawn in there. All right, the first equation has a y-intercept at positive 2, and then the slope is 2 over 1, so I'm going to rise 2, run 1. Now that doesn't give me a lot, so I'm going to also go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, just to get a more accurate graph. Now the second equation doesn't have a lot of information there. It's just y equals x. So we know there's a 1 in front, and I'm going to put it over 1. And since we're not adding anything, I'm going to put a 0 there, which means I'm starting at the origin of 0, 0, and then rising 1, running 1. And again, I'm just going to do that multiple times so that I can get a nice accurate graph. And when I do that, I see that they cross here, and that looks like it is at negative 2, negative 2. Substitution would be a great way to do this one as well, and so you don't have to use graphing. Number 2, again, just says solve the system. By looking at this one, it's not really set up for graphing. One of them is, but not both equations. And so I think I'm going to use substitution. Since I know y is the same thing as 2/3 x plus 2, everywhere I see a y, I'm going to replace it. And so I end up with negative 2x plus 3 times 2/3 x plus 2 is equal to 6. My first step will be to distribute and get rid of those parentheses. So 2/3 times 2x becomes, or times 3 becomes 2x, and 3 times 2 becomes 6. When I combine my like terms, something interesting happens. Negative 2x and 2x is eliminated, and I'm left with 6 is equal to 6. Now, guys, when I eliminate my variable, that means one of two things is happening. It's either a no solution or a mini solution. And when I look at this one, 6 equals 6 does make sense. So that's an infinitely many solutions. Number 3 asks me to estimate the solution. Since it's a graphing one, I'm just going to take a look at where those lines cross. It looks like the x is somewhere between 1 and 2, so I'm going to say maybe at 1.5. You may say 1.3 or 1.4, and that's perfectly fine since we're just estimating. But it does look like it's happening down there on the y around negative 4. So again, an estimate doesn't mean you have to have the exact same answer, but you should be somewhere close to that. Number 4 says Luke is selling cars for $12 each. His expenses are $3.50 per car, plus $30 for tools. How many cars must he sell for his revenue to equal his expenses? So the first thing I need to do is I need to write 2 equations. One to represent revenue, which is how much money he's making, and one to represent his expenses. So when I look at his revenue, how much money he's making, I see it says he's making $12 per car. So $12 times however many cars he makes will be the amount of money he's taking in. His expenses, on the other hand, are $3.50 per car plus the $34 he had to spend on tools. So now what I'm going to do is I'm going to figure out, when does revenue equal expense? In other words, when does 12C equal 350C plus 34? And so to do that, I'm just going to subtract 350C from each side in order to get my C's together. And I'm left with 850C is equal to 34. And dividing each side by 850, I get that C is equal to 4. So that tells me that he must need to make 4 cars for his revenue to equal his expenses. If he makes more than that, his revenue will be higher than his expenses and he'll start making money. Number 5 says, what's the solution to the system? So I look at it, it doesn't look like it's set up for graphing. it really doesn't look like it's set up for substitution. So I'd have to do some work if I wanted to use substitution. But it is set up to use elimination because not only are all my x's, y's, and numbers lined up, but I have opposites. So I can just jump straight into adding to eliminate. So 2x plus negative 2x is eliminated. That's what I want to happen. 5y plus negative 6y is negative 1y. And 14 plus negative 32 becomes a negative 18. If I divide each side by negative 1, I get that y is equal to 18. Now I need to plug that back into one of my two equations. I don't know that it really matters in this case. And so I'm going to plug into the top one and say 2 times x plus 5 times 18, and I want it to equal 14. So 2x plus 5 times 18 gives me an answer of 90. Then I'm going to subtract 90 from each side. Get 2x is equal to negative 76. And divide each side by 2 to get x is equal to negative 38. Now, this is kind of an odd answer for what we're used to getting. X comes first, then y. And so I might be a little unsure if this answer is actually correct. And so anytime I'm unsure, or if I just have some extra time, I can absolutely check by plugging in. So 2 times negative 38 plus 5 times 18. I can plug that in my calculator just the way I see it, hit the equal sign, and if I get a 14, then I know I have done that one correct. Then I check it in the other one as well, the other equation. So negative 2 times negative 38 plus 5 times 18. I hit equals, and I want to, again, this time I want to make sure that I have negative 32. So I'm checking that out. Negative 2 times negative 38 plus 5 times 18. I did not get that. Oh, because I wrote the wrong equation. Negative 2 times 38 minus 6 times 18, is equal to negative 32. Let's try that again. It's negative 32, 8 minus 6 times 18. That time I do get the negative 32. And so now I do know that that is the correct point. Number 6, again, asks me to solve or write the solution of the system. Guys, when I look at this, I wouldn't use graphing or substitution. They're just not set up for that. But the difference between 5 and 6 is this one does not already have opposites. So in order for me to do this one, I'm going to have to get opposites. So I'm going to choose to multiply the top equation by 3 and the bottom equation by 2. You could absolutely multiply by other numbers, but our goal is to get opposites. So if you'll see, when I do this, 3 times 5x becomes 15x. 3 times 2y becomes 6y, and 3 times 9 becomes 27. Down below, 2 times 4x becomes 8x. 2 times negative 3y becomes negative 6y, and 2 times 44 becomes 88. So now you can see the positive 6y and negative 6y are eliminated, so I can now add. So 15x plus 8x becomes 23x, and 27 and 88 becomes 115. Then dividing each side by 23, I get x is equal to 5. Okay, now I'm going to use that to plug back into one of my two equations. I'm going to choose the top equation, so I'm going to have 5 times 5 plus 2y is equal to 9. So 25 plus 2y is equal to 9. If I subtract that 25, I get y is equal to, or 2y is equal to negative 16. And then dividing each side by 2, I get y is equal to negative 8. So my solution is 5, negative 8. And just like up above, I could check that by plugging it in to be sure. All right, number 7 says the price of 6 slices of pizza and 4 drinks is $37. Guys, I'm just translating that sentence into a math problem. So 6p plus 4d is equal to 37. Now I'm choosing to use the variables p and d, p standing for pizza, d standing for drinks, but you could use whatever variables you would like. The second sentence says 4 slices of pizza and 6 drinks is $33. Now, much like question 6, this looks like an elimination problem. However, I am going to need to do some multiplying to get opposites. So I'm going to choose to multiply the top equation by 2 and the bottom equation by -3. And those may seem like weird choices to you, but if you'll see, when I multiply this first piece, I get 12p. The second one, I get 8d. And the third one, I get 74. Down below, I get -12p. There are my opposites. -18d and -99. Since I now have opposites, I'm ready to add to eliminate. My p cancels and I'm left with -10d is equal to -25. Dividing by -10, I get d is equal to 2.5. But since we're talking about money, I'm going to go ahead and put that 0 on there, meaning drinks cost $2.50. Now, since that's what they asked for, I really don't need to plug back in to find out how much pizza costs because it didn't ask me for that in this problem. However, if I had done this where I had solved for p first, then I would need to plug back in to solve for d. Guys, after question 7, we've really done the chapter 4 material, and so now we're just coming back to review some of the material from previous chapters. So questions 8, 9, 10, and 11 all deal with chapter 1. So we're just solving an equation. So I'm going to add 6 to each side and get 3x is equal to 24. Divide each side by 3 and get x is equal to 8. Number 9 is just more complex, but I'm going to start by distributing in. So 5 times 2x becomes 10x. 5 times -5 becomes -25. And then I just have the -7x and the plus 20 equals 7 still left. Combining like terms, 10x minus 7x becomes 3x. And -25 and positive 20 becomes -5. And now I have a much simpler equation that I'm going to add 5 to each side and get 3x is equal to 12, then divide each side by 3 and get x is equal to 4. Number 10 says graph and solve the inequality. Guys, an inequality is really nothing more than an equation with a different symbol. And so -7x minus 4 plus 3 is less than 6. Combining like terms, just like we did above, and I get -7x minus 1 is less than 6. I'm going to add 1 to each side and get -7x is less than 7. And finally, divide each side by -7. Now, I hope you remember when we multiply and divide with inequalities, when we multiply or divide by a negative number, that means we have to flip the symbol. And so I actually get x is greater than -1. So coming over here to my graph, I'm going to label a couple of boxes here, and I'm going to come and put an open circle at -1. Remember, if there's not an equal to sign, it's open. And then I'm going to graph to the right where x's are greater than -1. Okay, number 11 asks us to do the same thing, solve the inequality. We just don't have to graph this time. So I see x's on both sides, and so I'm going to work on getting those together. But something interesting happens when I do that. 3x minus 3x's, those are eliminated, and I'm left just with a -5 is greater than 2. Guys, when my variables are eliminated, that means it's either a no solution or a mini solution, and so I have to look at this inequality and see if it makes sense. Is it true that -5 is greater than 2? The answer to that is no, so that means no solution. B, very similar problem. If I subtract 7x from each side, I end up with 3 is less than 12. That is a true statement. 3 is less than 12, so because that's true, that means it's a many solution kind of problem. All right, now we move into chapter 2, writing an equation in point-slope form. Point-slope form tells me I need a point and a slope. They give me points, but they don't give me slope. So we have to start by finding slope by taking y minus y. Let me write this over here. Y minus y over x minus x. Now remember, when I take 5 minus a negative 3, that becomes plus a positive. So I end up with 4 over 8, and 4 over 8 reduces to 1/2. Now, writing that in point slope form, I pick one of my points. So I'm going to start with 5, 7. Y minus 7 is equal to 1/2 times x minus 5. And since they said point slope form, I can just leave it like that. Now, just in case you chose the other point, that equation would be y minus 3 is equal to 1/2 times x minus negative 3, which in fact is a plus positive. Guys, I would accept either answer on this problem. We're getting close to the end here. Chapter 3 now. It says identify the domain and range and then determine if this relation is a function. So if you'll remember, domain deals with x values. And so x values would be 4, 5, negative 3, 12. Oh, and 5 again. So I don't need to list that one twice. So I'm just listing my numbers. 4, 5, negative 3, 12 would be parts of my domain. My range are the y values. So in this case, it'd be 6, 7, 8, 4, and negative 6. No repeats on that one, so I'm just going to go ahead and write those all in. And then finally, is it a function? Remember, to be a function, every domain value can only go to one range value. And if you look at these 2 points here, I have the same domain value of 5 going to a range value of 7 or negative 6. And so that means no, it is not a function. All right, last but not least, question number 14 says Julia works at a bakery baking cakes. Each day she earns a set amount of plus a commission. Write a linear function to determine Julia's pay. So since it's asking me to write a linear function, that's asking me really to do what we just did on question 12. So we need to figure out the slope and we need a point. So slope is the change in y's. It looks like every change in y here is plus 2. Divided by the change in x's, it looks like every change in x is plus 1. So it looks like my slope here is 2 divided by 1, which is just a 2. Now I choose a point. You can choose any of them. I'm just choosing the first one, and we're going to write our equation. Y minus y, which is 12, is equal to the slope of 2 times x minus 1. Now, because it asks for a linear function, I'm going to go ahead and finish this out into slope-intercept form. So 2x minus 2. And then I'm going to add 12 to each side to get it in that slope-intercept form. Y is equal to 2x plus 10. Function notation would just say f of x equals 2x plus 10. Now, part B says, how much would she earn if she made 20 cakes that day? Well, one way that I could do that is I could just bring my table out and keep going. What if she made 6 cakes and 7 and go out to 20? But the shorter way would be now to use my function and say, well, the amount of money she makes is based on 2 times the number of cakes she makes plus that $10 set amount. And so 2 times 20 would be 40, and 40 plus 10 would mean she's making $50 per day if she makes 20 cakes. All right, guys, I hope that helped. If you've got any questions, make sure you're visiting with your teacher. Both of us offer before and after school tutoring times, and we're happy to help you. We want you to do well, and so make sure you're putting in the time and effort you need to be able to do your best. Thanks.